Hi, folks. This is Larry Mussolino. I'm recording a supplementary video for the Module 4 homework in STAT412. And I want to do a few other MyLab's homework problems to help you with some of these calculations. So I'm here. This is homework problem number 5. And it says, let X denote the number of times a certain numerical control machine will malfunction. Could be 1, 2, or 3 times on a given day. Y is the number of times a technician is called on the emergency call. There's a joint probability distribution in the table. Determine the covariance between X and Y. So the symbol here is sigma sub XY. We call that covariance. Well, there's a formula we can use to figure this out. There's a couple of formulas we can use. I think the best formula to use is the expected value of X times Y minus the mean of X, mean of Y, like this. All right, so we're going to need to calculate 3 parts then. We need the expected value here, the mean of X, mean of Y. All right, so let's start with the mean of X. Now for the mean of X, a formula we can use, because remember, this is a discrete distribution. We could say it's the sum of X times the marginal density function. We call it g of X. So we're going to need to figure out g of X. All right, well, let me open up this table and we can figure out g of X. So let me open up this data table and maybe I could put it over here. All right, so let's figure out g of X. Well, g of X is really going to be when X equals 1, let's make a little table here for g of X. When X is 1, 2, and 3, because those are the X values being given, I want to figure out g of X. G of X is the marginal density function. Marginal density function for X. All right, well, if you remember, the way you could do this is really sum up these probabilities in the column. So if I add up these probabilities here, this is 0.10. So that's the value of g of X when X is 1. When X is 2, I'm going to add up these probabilities, which is 0.35. So that's the value of g of X when X is 2. And then when X is 3, I'm going to add up these probabilities, which is 0.55, I think. Okay, and so that's 0.55. All right, well, now that we know these g of X values, the marginal density function, we can figure out the mean. So it's saying take the X value times its g of X and sum up those results. So this is going to be 1 times 0.1 plus 2 times 0.35 plus 3 times 0.55. All right, I'm just going to add these up. This is 0.1, this is 0.7, and this is 1.65, I think. So if I add these together, I think I'm getting 2.45. All right, but we also want to find the mean of Y. Well, in the same way, the mean of Y is going to be the sum of Y times its marginal density function. We usually write that as h of Y. All right, so let's write that out. For Y, the values here are 1, 3, and 5. So again, I'm going to make a little table here, 1, 3, and 5. And we want to find the marginal density function, h of Y. Well, for this, let me erase this. We really want to sum up the rows. So let's go ahead and do that. So when Y is 1, I'm going to add up these values across the row, which is 0.25 here. And the second row, this is when Y is 3. I think that's 0.55 here. And the bottom row is when Y is 5. That looks to be 0.2. So we have these values then for h of y, and let's figure out the mean of y. It's the sum of y times its marginal density function. So this is going to be 1 times 0.5 plus 3 times 0.55 plus 5 times 0.2. Just taking each y value times its corresponding h of y value. All right, if I work this out, let's see, this is 0.25 plus 1.65 plus 1. So what does this work out to be? 2.90, I think. All right, so we have mu sub x, the mean of x, we have mu sub y, the mean of y. The only thing we're missing is this expected value of x times y. Well, to find this, what we have to do is form all of the multiplications of x times y times their probability from this table. All right, so let's try to write this up. This is going to be a little messy, but let's try to do this maybe in an organized way. So here's what I'm going to do. Let me see if I can move this over a little bit here. All right, so we want to find out E of xy. So let me start forming all of the xy combinations. Well, x could be 1, y is 1. X could be 1, y can be 3. So these are, I'm going to write the x values here, the y values here, and then I'm going to put the probabilities here. Okay, and we're going to multiply all of these together. And then, of course, we're going to be adding these as we go down here. So there's going to be 1 and 5. Now let me move to the x value of 2. So there's a y value of 1, 3, and 5 to take into account when x is 2. And finally, when x is 3, y can also be 1, 3, and 5. All right, so these are all the combinations of x and y's. And I'm going to multiply them by their corresponding probabilities. So let's go to this first row. What about when x is 1 and y is 1? Well, when x is 1 and y is 1, according to this table, the corresponding probability is 0.05. How about when x is 1 and y is 3? Well, the corresponding probability for that is 0.05 too. X is 1, y is 5. At that intersection, I'm seeing a 0. All right, let's go now. X is 2, y is 1. Here's x is 2, y is 1. That's 0.05. So I'm going to write the rest quickly. 0.15, 0.15. I'm just copying these probabilities right out of the table. All right, so let me multiply these out quickly here. So the first row, we got a 1 times a 1 times a 0.05. That's 0.05. The second row, we got a 1 times a 3 times a 0.05. That's 0.15. This next row is a 0. Then we have a 0.1, 0.9 here, 1.5 there, because I'm just multiplying straight across here, 0.45, 3.15 for that, and down here, 0.75, I think, yeah. Now I'm just going to add these up. And if I add these up, I'm going to do this on a calculator, I think, quickly here. If I add these up, I think it works out to be 7.05. All right, now we have the pieces of the puzzle. So let me go back to this original formula and let's plug in. Get rid of some of this. Okay, so we just figured out that E, do this in green maybe. The expected value of x times y was the 7.05 number. The mean of X was this 2.45 number. And the mean of Y was this 2.90. So I'm just going to work this out on my calculator. If you work this out, the final answer here is negative 0.055. Call this the covariance, and it goes by this symbol sigma xy. All right, so the calculations are a little messy here, but break this down into 3 pieces. We had to find the mean of X, the mean of Y, and then the expected value of X, Y. Plug into this formula. All right, let's take a look at another example then. All right, let me come to another example here. This is example question number 8. And it's telling us here that X and Y are independent random variables. And it wants us to find the expected value of this combination, 2X minus 9Y. So when you have a linear combination, by the way, this is in section 4.3 in the textbook, we can rewrite this as 2 times the expected value of X minus 9 times the expected value of Y. So we're going to have to figure out is the expected value of X and the expected value of Y. Let's start with expected value of X. That's the sum of X times its marginal density function G of X. And so let's figure that out. Let me make up a little table here to get this marginal distribution of X. So maybe we'll make up a little table here. X can take on the values 2 or 4. And we have to find the values for G of X. Well, if you remember, really want to sum up these columns. So if I sum up this column here for X, I think this adds up to 0.7. And if I sum up this column, I think this sums up to 0.3. So we got 0.7 and 0.3. Now we can find the mean of the expected value. Sorry, the expected value is going to be 2 times 0.7 plus 4 times 0.3. Right, I'm taking each value of X times its corresponding value of G of X. All right, well, this is 1.4, and this is 1.2. So this works out to be 2.7. All right, well, let's do the same thing for the expected value of Y. This is going to be the sum of Y times H of Y. And H of Y is the marginal distribution for Y. So let's make a little table for that. The Y values are going to be 1, 3, and 5. 1, 3, and 5. And to get the marginal distribution for Y, I'm going to be adding straight across. Let me erase some of this stuff. So I'm going to be adding straight across and adding these two probabilities together. If I do that, I think I'm getting 0.25 going across here. 0.35 for this row. And if I add across for the last row, 0.4. All right, so we ended up here with 0.25, 0.35, and 0.4. Now we can find the expected value of Y. It's going to be 1 times 0.25 plus 3 times 0.35 plus 5 times 0.4. Okay, and if I work this out, I think this works out to be 3.3. All right, so I'm ready to plug in then. So the what I need here is 2 times the expected value of X. We just figured that out to be 2.7. And back here, I'm going to subtract 9 times expected value of Y. That's 3.3. I'm just going to work this out on my calculator. I get negative 24.5. So this is the answer for part A. All right, let's go to part B. Part B says, what's the expected value of xy? Well, it's important to note here that they're telling us that x and y are independent. So if you go in section 4.3 again in the textbook, you'll see the indication that says the expected value of x times y. It can be written as E expected value of x times expected value of y when x and y are independent. Well, that means I just have to multiply 2.7 times 3.3 here to get this answer. This works out to be 8.58. Okay. All right, let's do maybe one more, perhaps. Let's take a look. All right, folks, let me take a look at an example here. This is example 10, question 10 from the homework. And here's what it says. Let x represent the number that occurs when a four-sided red die is tossed. Y, number that occurs when a four-sided green die is tossed. Let's go to part A. Part A says, find the expected value of x plus y. Well, we can write this as the expected value of x plus the expected value of y. So what we need to do is find expected value of x, expected value of y, and we'll have what we need. So let's think about expected value of x. Well, this is a discrete distribution, right? Because x can only take on the value 1, 2, 3, or 4. So this is going to be the sum of x times f of x. All right, well, f of x really is just going to be 1 over 4, right? Because the probability of getting any particular value of x is 1 over 4. So the way I can write this is the sum from x equal 1 to 4 of x times f of x, which is 1 over 4. Well, I could pull the 1 over 4 out in front of the summation because it doesn't depend on x. So this is just going to be the sum x equal 1 to 4 of x. So this is going to be 1 over 4, 1 plus 2 plus 3 plus 4. Well, that's 10 over 4. 10 over 4 I can write as 2.5. All right, let's find E of y, expected value of y. Well, really, it's going to be the same exact value because when you do the sum of y times f of y, it's the same scenario. It's a four-sided die, so f of y is going to be 1/4. So I'm going to end up with the same answer, 2.5. So if I come back here and plug in, the expected value of x was 2.5, the expected value of y was 2.5, so this answer is 5. All right, so let's go to part B. Part B says, what's the expected value of x minus y? Well, I could write this as expected value of x minus expected value of y, but this is just going to be 2.5 subtract 2.5. That's a 0. And the last one is expected value of x times y. Well, here the results are independent, right? What happens, the number that comes up on the red-sided die is in no way affected or influenced by the number that comes up on the green-sided die. So we can assume here x and y are independent. Well, if that's the case, we can write this as E of x times E of y. And that's going to be 2.5 times 2.5, which is 6.25. By the way, just a side comment here, you know, when you're adding up a series like this, 1 plus 2 plus 3 plus 4, there's a little shortcut in case you need to add up, let's say, the first 50 numbers. The shortcut looks like this. If you want to add up 1 plus 2 plus 3 plus, let's say, up to n, the shortcut formula is you take n times n plus 1 over 2. So let's say I was adding up the numbers from 1 to 50. Well, in this example, n is 50, so this would be 50 times 51 over 2. Because, of course, I don't want to count, I don't want to add up all of these 50 numbers. I want a shortcut formula. So you can use that formula if needed. All right. Folks, let me do one more example here. All right, folks, let's look at this example. This is question 9. It says here, if x and y are independent random variables, the variance of x is 5, the variance of y is 2. Find the variance of this random variable called c that's formed by negative 4x plus 5y minus 8. All right, well, for this, we need a formula that looks like this. If you want to know the variance of this linear combination, ax plus by plus c, the way you set this up is you take a squared times the variance of x plus b squared times the variance of y plus 2ab, the covariance of xy. All right, now remember they're giving us that c is negative 4x plus 5y minus 8. I'm going to compare this to ax plus by plus c. So when I do this comparison, a is matching up to negative 4, b is matching up to 5, and c is matching up to negative 8. All right, now one other thing I have to take into account is, this problem is telling us that x and y are independent. Well, if x and y are independent, that means the covariance is 0. Are independent, then this covariance is 0. So I'm going to plug into this formula. All right, a squared. Our a value here is negative 4 squared sigma x squared. The variance of x that was given to us is 5 in the problem. All right, what about b squared? Our b number was 5, so that's 5 squared. The variance of y was given to us in the problem is 2. Then we have 2 times a is negative 4, times b, our b is 5. The covariance is 0. So this last term, of course, drops out. So this is going to be 16 times 5 plus 25 times 2. This is 80 plus 50. So we get the answer here, 130. Okay, so this is the formula we needed for this example. All right, folks, hope this is helpful as you're working in the Module 4 homework.